Our planet Earth, a celestial body that has fascinated humanity for millennia, a sphere of vibrant blue and swirling green, a delicate balance of land and water, a place teeming with life, from the tiniest microorganisms to the largest mammals. But have you ever wondered how this remarkable planet came to be? How did this oasis in the vastness of space form? It's a story that stretches back billions of years to a time when the universe was young and chaotic. A tale of cosmic dust, fiery collisions, and the relentless forces of gravity, and the slow, steady march of time, shaping and reshaping the surface of our planet. This is the story of Earth's formation, a process that began in a swirling cloud of gas and dust. A journey from a chaotic cloud of gas and dust to the formation of the solar system, to the development of oceans and land masses, creating the conditions necessary for life. It's a story that's still unfolding, as our planet continues to evolve and change, a testament to the power of nature and the dynamic processes that shape our world, and the wonders of the cosmos, reminding us of our place in the universe and the incredible journey that brought us here. Our story begins some 4.6 billion years ago in a vast cloud of gas and dust called the Solar Nebula. Imagine a swirling mass, dark and cold, stretching light years across space. This nebula, this cosmic nursery, was the birthplace of our solar system. The Solar Nebula wasn't just any cloud of gas and dust. It contained the building blocks of planets, stars, and even life itself. Hydrogen and helium, the most abundant elements in the universe, swirled alongside heavier elements like carbon, oxygen, and iron. Within this swirling cloud, a drama began to unfold. Gravity, the invisible force that draws matter together, started to pull the nebula's particles towards each other. As the cloud contracted, it began to spin faster and faster, like a figure skater pulling in their arms. This spinning motion flattened the cloud into a disk, a cosmic whirlpool with most of the material concentrated at its center. This central region, glowing brighter and hotter, would eventually become our sun. As gravity pulled more and more material into the center of the disk, the temperature and pressure skyrocketed. Atoms, once drifting freely, were now colliding with incredible force. This intense heat and pressure triggered a nuclear reaction, igniting the core of our newborn sun. The sun blazed to life, bathing the surrounding disk in light and heat. This marked a turning point in our story, the moment our solar system began to take shape. While the sun ignited at the center, the outer regions of the disk were also undergoing a transformation. Dust grains, tiny particles of rock and ice, were clumping together through electrostatic forces. These clumps, drawn together by gravity, grew larger and larger, forming objects called planetesimals. These planetesimals, some as small as pebbles and others hundreds of miles across, were the seeds of planets. They zipped around the young sun, their paths crossing and colliding in a chaotic dance. In the inner region of the disk, where Earth was forming, the temperatures were too high for ices to survive. Rocky planetesimals, composed of elements like iron and silicon, collided and stuck together, gradually growing into larger and larger bodies. One of these growing bodies, destined to become our home, swept through its orbit, accreting more and more material. Over millions of years, this protoplanet grew into the young Earth, a hot, molten ball of rock. The intense heat within the young Earth wasn't distributed evenly. This uneven distribution of heat led to a dynamic and tumultuous environment with volcanic eruptions and molten rock flowing across the surface. The early Earth was a fiery, chaotic place, constantly reshaping itself. Denser materials like iron and nickel sank towards the center, driven by gravity. This movement was crucial in forming the planet's core. As these heavy metals descended, they released even more heat, further fueling the planet's internal processes. Meanwhile, lighter materials like silicates rose to the surface. These materials formed the early crust and mantle, creating a layered structure. The rising silicates also contributed to the formation of magma, which occasionally broke through the surface in dramatic volcanic eruptions. This process, called differentiation, shaped Earth's internal structure. Differentiation was a critical phase in Earth's development, leading to the distinct layers we see today. It was a period of intense change and transformation, setting the stage for the planet's future evolution. Earth's core, a sphere of solid iron and nickel, formed at the planet's center. This solid inner core is incredibly dense and hot, with temperatures comparable to the surface of the Sun. It plays a vital role in generating Earth's magnetic field. Surrounding the core, a layer of molten iron and nickel, the outer core, came into being. This liquid layer is in constant motion, creating convection currents that drive the geodynamo, which in turn sustains Earth's magnetic field. Above the outer core, a thick mantle of hot, viscous rock took shape. The mantle is the largest layer of Earth, composed of a semi-solid rock that flows slowly over time. This flow drives plate tectonics, causing continents to drift and collide. And finally, at the surface, a thin crust of solidified rock began to form. This crust is the outermost layer of Earth where we live. It is relatively thin compared to the other layers, but it is crucial for supporting life and shaping the planet's surface features. While Earth was still in its infancy, a cataclysmic event occurred that would forever shape our planet. A Mars-sized object named Theia collided with the young Earth in a colossal impact. The impact sent shockwaves through the young Earth, melting its surface and blasting debris into space. This debris, caught in Earth's gravitational pull, coalesced over time to form our moon. Over millions of years, the early Earth began to cool. The molten surface solidified, forming the first continents. Volcanic eruptions, spewing gases from Earth's interior, shaped the landscape and released water vapor into the atmosphere. As Earth continued to cool, water vapor in the atmosphere condensed, forming clouds and raining down on the surface. This relentless rain filled the low-lying areas, creating the first oceans. Volcanic activity played a crucial role in shaping Earth's early atmosphere and oceans. Volcanoes released gases like water vapor, carbon dioxide, nitrogen and methane, creating a thick, steamy atmosphere. These gases, trapped by Earth's gravity, formed the building blocks of our atmosphere. Water vapor condensed to form the oceans, while other gases created a protective blanket around the planet. In the warm, shallow waters of Earth's early oceans, life emerged. These waters, rich in minerals and bathed in sunlight, provided the perfect cradle for the birth of life. The conditions were just right for the complex chemical reactions that would eventually lead to the formation of living organisms. Simple, single-celled organisms, the ancestors of all life on Earth, appeared around 3.8 billion years ago. These microscopic pioneers were incredibly resilient, capable of surviving in the harsh conditions of early Earth. They harnessed energy from their surroundings, setting the stage for more complex forms of life to develop. These early life forms thrived in the primordial soup, their existence a testament to the power of life to arise in the most unexpected of places. The primordial soup was a rich mixture of organic compounds, providing the essential building blocks for life. These microorganisms multiplied and evolved, gradually increasing in complexity. Over billions of years, life evolved and diversified, from simple bacteria to complex plants and animals. This incredible journey of evolution saw the emergence of multicellular organisms, the development of photosynthesis, and the rise of oxygen in the atmosphere. Each step in this process was a monumental leap forward in the history of life on Earth. Earth's oceans and continents teemed with an astonishing array of life, each species uniquely adapted to its environment. From the depths of the oceans to the highest mountains, life found a way to thrive. The fossil record reveals a rich tapestry of prehistoric ecosystems, showcasing the incredible diversity and adaptability of life throughout Earth's history. From a swirling cloud of gas and dust to the vibrant planet we call home, Earth's journey is a testament to the wonders of the cosmos. Shaped by gravity, time and chance, Our planet stands as a beacon of life in the vastness of space. Earth's unique combination of factors, from its distance from the sun to its protective atmosphere and magnetic field, has allowed life to flourish for billions of years. It is a precious oasis, a testament to the power of nature and the fragility of life.